In this video, we will practice simplifying expressions with exponents. In the last video, we reviewed the properties of exponents. So if you haven't seen that, you should probably watch that first. You can either click the link that appears in the upper right-hand corner or find the link in the description. To simplify problem number 1, we need to rewrite it so that all of the variables have positive exponents. When a variable has a negative exponent, it means that it is on the wrong side of the fraction line. So this x to the negative 2 power will have to drop down to the denominator, and y to the negative 3 power will go up to the numerator. Notice that the 7 does not have a negative exponent. It is not connected somehow to the y. So the 7 will stay in the denominator. So I will bring the x squared down and make it a positive 2 power. And I will take the y up and make it a positive 3 power. That's all we can do for number 1. Number 2, the negative exponent tells us that this expression is on the wrong side of the fraction line. So I'm going to drop it down to the denominator. So now we have this. 8 over 4 reduces to 4 over 3. The n in the denominator will cancel out one of the n's in the numerator, leaving behind n squared. P squared times p to the 4th power is p to the 6th power. When you multiply like bases, you add the exponents. So that's it for number 2. Number 3, when you raise a power to a power, you multiply. So we get m to the negative 6th power times v to the negative 8 power. But these negative exponents tell us that these expressions are on the wrong side of the fraction line. So we need to drop both of these down to the denominator. We get 1 over m to the 6th v to the 8th. And that's the final answer. On number 4, I see negative exponents here, here, and here. Each of these factors will move to the opposite side of the fraction, while the 2, the 6, and the c to the 3rd power stay where they are. So the b to the negative 2 power will move up to the numerator and become b squared. Similarly, the b to the negative 5th power will drop down to the denominator and become b to the positive 5 power. C to the negative 6 will drop down as c to the positive 6 power. 2 over 6 reduces to 1/3. The 2 b's in the numerator will cancel out 2 of the b's in the denominator, leaving behind b to the 3rd power. C to the 3rd times c to the 6th is c to the 9th. When you multiply like bases, you add the exponents. So that's it for number 4. Number 5, I see a negative exponent right here. So this factor is on the wrong side of the fraction. It needs to drop down to the denominator. The 3 and the y squared will stay where they are, but in the denominator we now have x to the positive 5 power. So that's it for number 5. Number 6, we have a negative exponent right here. So this factor has to move to the numerator. That's going to leave us with 5 times n to the 4th power. Kabam! Number 7, we are multiplying these expressions. So we have 4 times 5, which is 20. When you multiply variables with like bases, you add the exponents. So b to the negative 6th power times b to the 2nd will be b to the negative 4. Negative 6 plus 2 is negative 4. This c right here is like c to the 1 power. So c squared times c to the 1 will be c to the 3 as we add those exponents. Notice that we do have a negative exponent right here, which means that this factor is on the wrong side of the fraction and must drop down to the denominator. So we end up with 20c cubed over b to the 4th power. Number 8, first we multiply negative 2 times 6 and we get negative 12. Now, when you multiply with like bases, you add these exponents. So we end up with x to the 3rd power. Negative 3 plus negative 2 is negative 5, so we have y to the negative 5 power. Notice that we have a negative exponent right here. That means that this factor is on the wrong side of the fraction and must drop down. I just remembered a common mistake that students will make. They get used to seeing something negative and dropping it down. Am I going to take this negative 12 and drop it down? Absolutely not. Please do not make that mistake. This is not an exponent. It's just a negative 12. It's not going to move anywhere. That's it for number 8. On number 9, I want you to be very careful about how you handle the negative 5 and the 2. Sometimes it helps if you erase the other two factors. So now you can see that we have negative 5 squared. That will be positive 25. Now let's bring back the other two factors. N to the 4th power squared. When you raise a power to a power, you multiply. So this will be n to the 8th power. Of course, p squared is just p squared. Kabam! Number 10, be careful with the 4. If we erase these factors, it's a bit easier to see that we have 4 squared. So this will be 16, not 8. And then we can uncover the factors, and we have x to the negative 3 power squared. That will be x to the negative 6 power. When you raise a power to a power, you multiply. Similarly, we have y to the 10th power. Notice that we have this negative exponent here. That means that this factor is on the wrong side of the fraction and must be dropped down to the denominator. We end up with 16y to the 10th power over x to the 6th power. Negative 3 to the 3rd power is negative 27. K to the negative 6th power cubed is k to the negative 18th power. When you raise a power to a power, you multiply. Similarly, we have n to the negative 24 power, multiplying these together. Of course, p to the 3rd power is simply p to the 3rd power. I notice that we have two factors that have negative exponents. Both of these are on the wrong side of the fraction and must be dropped down to the denominator. Notice that the negative 27 is not going anywhere. This is not a negative exponent. It's just a negative number. It's going to stay right where it is. So this is the final answer. Number 12. Students often get confused about how to raise a number to a negative power. My recommendation is to temporarily just write 4 to the negative 3 power and then come back to it later. B squared to the negative 3 power will be b to the negative 6 power. When you raise a power to a power, you multiply. Of course, c to the negative 3rd is just c to the negative 3rd. Notice that every single one of these factors has a negative exponent. That means we will drop all three factors down to the denominator. So we end up with 1 over 4 cubed times b to the 6th power times c to the 3rd power. Or you can write 4 cubed as 64. On number 13, a common mistake is to multiply 6 times 6 and get 36. Don't do that. When you multiply with like bases, you add the exponents. So you will have 6 to the 3rd power, or 216. On number 14, let's bring down the negative 3x squared for now. We need to raise the other factor to the 7th power. So we will simply put 3 to the 7th power. I don't know what that is. I'm just going to leave it like that. And when we raise a power to a power, we multiply. So we will have 3 to the 7th times x to the 21 power. Now we need to multiply these two factors together. When we multiply 3 times 3 to the 7th power, it might help to think of this as 3 to the 1 power. I'm just going to bring down that negative sign. But then 3 to the 1 power times 3 to the 7th power will be 3 to the 8th power. X squared times x to the 21 will be x to the 23. When you multiply with like bases, you add the exponents. Kabam! Number 15, let's start by raising this part to the second power. So we will have 4 squared, which obviously we could put 16. X to the third power squared will be x to the 6th power. When you raise a power to a power, you multiply. Similarly, we will have y to the 10th power. Now let's do this part. Raising each factor to the third power, we have 2 to the third power, and yes, that is 8. And then we have x to the third power and y to the 21 power. When you raise a power to a power, you multiply. Now we need to multiply all of this together. For a brief moment here, I'm going to write 4 squared times 2 to the third power. Now I have x to the 6th power times x to the third power. When you multiply with like bases, you add the exponents. So this will be x to the 9th power. And then y to the 10th times y to the 21st will be y to the 31 power. So this is one way to write the answer. Let me show you a couple other ways. Focus on this part right here. 4 squared is the same thing as 2 squared squared, right? So times 2 to the third power. Now we have a power raised to a power, so we multiply. That will give us 2 to the 4th power times 2 to the third power. I rewrote it this way so we would have like bases. Now we can multiply by adding the exponents. So this would make 2 to the 7th power. So here is another way to write the answer. Or instead of writing 2 to the 7th power, you could write 128. The negative exponents tell us that both of these factors are on the wrong side of the fraction bar. So we can rewrite this as 5 to the 4th power over 5 to the 6th power. Now here's something that I wouldn't normally write down, but I'm picturing 5 to the 4th power as 5 times 5 times 5 times 5. So I have 4 5s. Similarly, I have 6 5s in the denominator. The 4 5s in the top will cancel out 4 of the 5s in the bottom. That's going to leave 2 5s in the bottom. So the answer will be 1 over 5 squared, or 1 over 25. And again, you wouldn't write this down. This is just what you picture in your head. Number 17 has a lot going on. Let's start by getting rid of this factor, because if you raise something to the 0 power, it becomes a 1, which we then don't need to write down. For now, I am going to leave 4 to the negative 2 power, and I want to get rid of the parentheses. So let's raise each one of these factors to the 5th power. So x to the 5th power and y to the 5th power. We're going to raise a power to a power by multiplying. So we get x to the negative 10 power and y to the 6th power. Now let's look at anything that has a negative exponent and move it to the other side of the fraction. So this is going to go down, while this is going to go up. Notice that these 3 factors will sit right where they are. So in the numerator, we now have a brand new x to the 10th power, and in the denominator, we have 4 squared. Next, we will multiply x to the 10th times x to the 5th power by adding these exponents. The 4 squared is just going to sit there. I guess we can go ahead and put 16, because why not? The 5 y's in the numerator will cancel out 5 of the y's in the denominator, leaving behind a single y. So that's the final answer. Number 18. I'm just going to recopy a few things. So we have x to the 4th power. These parentheses really are not doing anything. They don't even need to be there. So I'm just going to write down x to the 3rd power, y to the 5th power, and x to the negative 6th power. So the very fact that they wrote 2 separate fractions is meaningless. So I just connected them as one. Anyway, in the denominator, we can raise a power to a power by multiplying. So we get y to the negative 6th power. And again, I'm just recopying what I see. So we have x to the negative 5th power and y to the negative 2 power. So in the numerator, we have x to the 4th power times x to the 3rd power times x to the negative 6th power. We can multiply all these together by adding all three exponents. 4 plus 3 is 7, plus negative 6 is 1. So really that's just x. We only have the single factor of x in the denominator, so there's my x to the negative 5 power. And we can multiply y to the negative 6 times y to the negative 2 by adding these exponents. So that will be y to the negative 8 power. Since both of these have negative exponents, that means they are each on the wrong side of the fraction line. So they will both go up to the numerator and join the x. So now we have this. Of course, x times x to the 5th power is x to the 6th power. So this is the final answer. Number 19. This entire numerator is going to become a 1, because if you raise something to the 0 power, it's a 1. So we have 1 over, now I'm raising a power to a power in all of these cases, except when looking at this negative sign, I'm really looking at this as a negative 1. Negative 1 to the negative 1 power is still a negative 1. So I'm just going to bring that down. I'm emphasizing that because if this had been a 2, for example, negative 1 to the 2nd power would be positive 1. So there would be no negative sign here. But it wasn't, so back to this. For the rest of this, I am going to simply multiply all of these exponents by negative 1, because when you raise a power to a power, you multiply. So we will have 3 to the negative 4 power, a to the negative 5 power, b to the positive 3 power, d to the positive 2 power. Notice that we have two factors with negative exponents. So both of these need to move to the other side of the fraction. So this is the final answer. Number 20. I'm going to rewrite this without so many parentheses. So I'm just going to bring down the negative 3 to the 4th power. These parentheses are just plain not necessary because there is no exponent or anything. So we just have times x squared times y to the negative 2 power. Now this part is being raised to the 2nd power. So I am going to have 4 squared, which I think I'll just put 16. So I'll put times 16. And then raising a power to a power, you multiply. So that's y to the negative 2 power. Similarly, x to the 5th power cubed will be x to the 15th power, and we will have y to the 6th power because of 2 times 3. And then these parentheses are not needed. I'm just going to bring down my x to the negative 8 power. So we have this negative 3 to the 4th power and 16. I'm just going to awkwardly put these in the front. So I have 3 to the 4th power times 16, or you could have left it as 4 squared if you wanted to. But now to the variables. We have x squared, x to the 15th power, and x to the negative 8th power. We need to add all of these exponents. So 2 plus 15 is 17, minus 8 is 9. So we have x to the 9th power. Similarly, we will add up all of the exponents on the y's. So negative 2 and negative 2 is negative 4, plus 6 is 2. So we have y squared. And here are a couple other versions of the answer. We are down to the last two problems. I'm just going to bring down the 3x to the negative 5 power for now. When you raise a fraction to an exponent, you raise the numerator to the power and the denominator to that power. So I will have x to the And a power to a power you multiply. So this will be x to the negative 8 power over y to the negative 4 power. So let's come back to that. Here, let's go ahead and do this right here. We have a power raised to a power. So this is going to be the positive 6 power. So I'm going to have x y to the negative 2 power over y, all raised to the positive 6 power. When you raise a power to a power, you multiply. So I get this for the last fraction. Now I notice that I have negative exponents here, 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 and here. All four of these factors need to switch to the opposite side of the fraction. Notice that the 3, the x to the 6th power, and the y to the 6th power stay exactly where they are. But I will now have x to the 5th power in the denominator, y to the 4th power in the numerator, x to the 8th power in the denominator, and y to the 12th power in the denominator. Smooshing these three fractions into a single fraction, I have 3 x to the 6th power, y to the 4th power in the numerator. I have x to the 5th power times x to the 8th power. That will be x to the 13th power as I add these exponents. And similarly, I have y to the 18th power. Now, let's cancel out some of these extra x's and y's. The 6 x's in the numerator will cancel out 6 of the x's in the denominator. So that's going to leave behind 7 x's. So x to the 7th power. These 4 y's will cancel out 4 of these y's, leaving behind y to the 14th power. So this is the final answer. Last one, number 22. When you raise a power to a power, you multiply the exponents. So we will have g to the 16th power, h to the negative 20 over h to the positive 12, g to the negative 24. Those are some big exponents, man. And I'm just copying this part down. Let's form a single fraction by multiplying the numerators together and multiplying the denominators. So g to the 16th power times g squared will be g to the 18th power. And I simply bring down my h to the negative 20. Now, g to the negative 24 times g to the 5th. If I add those, I get negative 19. So I get g to the negative 19. H to the 12th times h to the negative 7. If we add those exponents, I get h to the 5th. The g to the 18th power and the h to the 5th power will stay right where they are, but the two factors with a negative exponent will change sides. So this one will drop down to the denominator, and this one will go up to the numerator. So we will now have an extra g to the 19th power in the numerator and h to the positive 20 in the denominator. When you multiply like bases, you add the exponents. So we get g to the 37 over h to the 25.